So using trig ratios, and again, this is a review from grade 10, we're going to take a look at how do we find the length of a side. Now, generally, that's maybe a little bit easier to do as there's less steps involved, or one less step involved. We're going to take a look at how do we find the length of a side based on an angle. So let's take a look at a few examples. This first one here on the top left, we're given an angle of 42 degrees. We have side A and we have a side length of 12. Now, in this case here, this is a right angle triangle, so that's important that we look at. The first thing that we always got to make sure that we do is label our sides. If this is the angle that we have here, this part doesn't really matter. This is going to be our hypotenuse. It's our longest side. It's across from the 90 degrees. The one that is across from the 42, our given angle, is going to be our opposite side. So this is going to be our opposite side. And that means that this is then our adjacent side. Okay, so those are our three sides. We make sure we label that right off the bat. Now we could also label it A, B, C, or put other things in there, but we don't have to do that in this case. We're just trying to solve for what is our side length and what is side A in this case right here. Now, because of the situation that we have, we are given the hypotenuse and we're trying to find the opposite. We need to use our trig ratio, which includes opposite and hypotenuse. And so going up a little bit farther here, the one that includes the opposite and hypotenuse is our sine ratio. So we're going to be using our sine ratio to solve this question here. So sine of theta, and we're going to put in our theta there, here we go, is equal to the opposite over the hypotenuse. So this is the equation that we're going to be, or the function that we're going to be using to solve this one, because we are looking for the opposite and we know the hypotenuse. All right, so now let's put in everything that we know into our equation here. We know that our angle is 42 degrees. We're going to put that in for theta. Our opposite is A. We don't know what A is in this case, but our hypotenuse is 12. So we're going to do sine of 42 degrees is equal to the opposite, which is A, over 12. Now, to solve this, some of you may have learned how to do it algebraically. Some of you may have learned how to just go cross multiply and divide. I'm going to show cross multiply and divide in this case here. If we're otherwise, we would just multiply by 12. So that would work. With cross multiply and divide, I always make it into a fraction. And then we're going to take the one on the right here because we have our missing one here. So the start on the right, we go across, so we're going up and we multiply. And then we go down to the bottom and we divide. And that is going to equal to our answer. So what that means is that our the equation, or the process that we're going to go through, is we're going to do 12. Oops, make this into an equation here. Let's use math type. Times sine of 42 degrees. And we're going to divide by 1, which doesn't really matter because it doesn't actually change it. But this is going to give us our answer. And so we're going to just kind of follow this process right here. Now I'm going to pull up my calculator right here. And so to do this, I'm going to do 12 times sine of 42 equals. And I got an answer of 8.03. Remember, use 2 decimal places. And because this is a number 5 or higher, we're going to round it up to a 3. So our answer is 8.03. That's the length of this side right here. Now that's all we're being asked for. We're not being asked to find the adjacent side. We're just being asked to find A. So this is all that we would have to do. Okay, given that based on what we know. Let's take a look at a slightly different one. This one's just going to kind of again mix it up a little bit. Okay, so let's start with labeling our sides. First of all, we know that this is theta right here, and I didn't label it on the other one, but I will label it here. Okay, this is our angle. We're given an angle of 33 degrees. Okay, and so what that tells us is that this is our hypotenuse. Again, it's crossing the right angle, so that's just always the case. B is going to be our opposite. So again, it looks like we're trying to find our opposite. and this side here is going to be our adjacent side. So here we are given the adjacent side, and we want to try to find the opposite side. So we'll go here, which of our ratios has opposite and adjacent, and that would be our tan ratio. And so the equation or the function that we're going to be using is our tan ratio. So tan of theta is equal to opposite over adjacent. Like I said, if you don't have these memorized, all of the ratios, that's okay. You can use a cheat sheet for the assessment, so that's not a problem. You don't need to have those memorized. All right, let's plug in all of the values that we know. So we know our angle is 33 degrees. And we know that our opposite, well, we don't know our opposite, it's B. So we're just going to put B in there. And our adjacent is 12. So to find this, again, same thing, multiply by 12, or use cross multiply and divide. And that will give us our B value there. So I'm just going to put that in. I'm going to make this over 1. I'm going to go across, and then I'm going to divide, and then it's going to be equals. Just going to slide that up a little bit. And so to come up with our answer, we are going to do tan of 33 degrees, sorry, 12 times. Tan of 33 degrees divided by 1 is equal to, I'm going to have to slide that over a little bit so it fits all on the page. Let's do it with the calculator again. Clear that off. 12 times tan, or there's my tan, of 33. And that equals 7.79. And so the answer right here, again, to 2 decimal places, 7.79. We don't have any units, so we don't have to worry about trying to find a unit. Okay, so this is when, again, we're given the value that's in the denominator here, and we're trying to find the numerator. Probably the easiest of the ways to do it. Let's mix it around a little bit. We're going to try to find, we're going to do the opposite, where we're going to be given the denominator. Okay, so we have the adjacent. We're trying to find the hypotenuse. This is our opposite side. I'm going to go through something that's a little bit quicker because it should be fairly straightforward. Sorry, or dry throat here. Too much talking, I guess. Adjacent and hypotenuse. So we're going to be using cos of theta is equal to adjacent over hypotenuse, and plug our values in. So cos of 75 degrees is equal to the adjacent, which is 9, over the hypotenuse of C. And again, as I mentioned, I'm going to use cross multiply and divide. So now instead of starting on the bottom, I'm starting on top. I'm going to be multiplying by the 1 that is down here. And then I'm going to be dividing by cos of 75, and that's going to equal to our C. And the way that that's going to look when we solve is that we're going to have 9 times 1 divided by cos of 75 degrees. And you might notice that you can just do 9 divided by cos of 75 degrees. You don't actually even have to do the 1 in there. So I'm going to do 9 divided by cos of 75, and that equals 34.77. And so the answer in this case here is 34.77. Again, now we're dividing by our angle instead of multiplying by it. Now on your calculators, make sure that you recognize how to do cos. I would suggest that you try these out and practice them. Make sure you're getting the same answer that I am, because there's different ways. Sometimes you have to do the cos first, sometimes you have to do cos second when you are solving for it. So make sure that you recognize how to do it with your calculator, because that is a very common way of making a mistake or not getting the correct answer. All right, so we're going to do this one here really quick. Okay, we have the opposite. We're trying to find the adjacent, and I'm going to do this just a little bit lower here. And let's get a text box. So opposite and adjacent, this is our tan tan feature or tan function. Tan theta is equal to opposite over adjacent. And then, oops. We're going to plug in the values that we know. So tan of 24 degrees is equal to the opposite side, which is 15, over the adjacent, which is D. And now I'm going to just jump right into that. We've seen the cross multiply and divide. What we're going to do here is same thing that we did here. We're going to do 15 times 1 divided by tan of 24 degrees. And remember, we don't even need to do the times 1. We can just divide by tan of 24 degrees. And so then to do that, 15 divided by tan of 24 degrees. We should get 33.69. And so our answer is 33.69, and that would be the length of this side here. A couple things to really watch for with length. The hypotenuse should always be the longest. So if you get a longer side for an opposite or adjacent, be careful about that. If our angle is below 45, the adjacent will be bigger than opposite. If the angle is above 45, then the opposite will be bigger than the adjacent. Okay, so there's a couple things just to be aware of and a couple things to think about as you are going through these questions.